Question 1. What is the primary goal of model optimization in ML Ops? Option A. To achieve the highest possible predictive accuracy regardless of computational cost. Option B. To primarily reduce the number of features used in a model. Option C. To enhance a trained model's efficiency and performance characteristics for deployment without significantly compromising accuracy. Option D. To automatically generate new training data for the model. The correct answer is to enhance a trained model's efficiency and performance characteristics for deployment without significantly compromising accuracy. Here's the explanation. The primary goals of model optimization include reducing inference latency, minimizing memory footprint, decreasing computational resource consumption, and thus operational costs, and improving throughput, often without significantly compromising its predictive accuracy. Question 2. Which model optimization technique involves training a smaller, simpler student model to mimic the behavior and outputs of a larger, more complex teacher model? Option A. Quantization. Option B. Pruning. Option C. Knowledge distillation. Option D. Graph optimization. The correct answer is knowledge distillation. Here's the explanation. Knowledge distillation is defined as training a smaller, simpler student model to mimic the behavior and outputs of a larger, more complex teacher model, effectively transferring knowledge and achieving similar performance with fewer parameters. Question 3. For which use case is model optimization, particularly techniques like quantization and pruning, most critical due to strict resource constraints? Option A. Batch processing of large datasets on powerful cloud servers. Option B. Training a large language model on a supercomputer. Option C. Deploying real-time object detection models on mobile phones or IoT sensors. Option D. Storing historical model versions in a model registry. The correct answer is deploying real-time object detection models on mobile phones or IoT sensors. Here's the explanation. Edge device deployment is listed as a use case where models must operate within strict resource constraints, limited memory, processing power, battery life, making optimization techniques like quantization and pruning crucial for efficiency directly on the device. Question 4. What is the primary motivation for performing model compression in ML Ops? Option A. To increase the model's accuracy on unseen data. Option B. To reduce the model's size and computational requirements for more efficient deployment. Option C. To make the model more complex and difficult to reverse engineer. Option D. To completely eliminate the need for model retraining. The correct answer is to reduce the model's size and computational requirements for more efficient deployment. Here's the explanation. The primary motivation for model compression is to reduce the size and computational requirements of machine learning models while preserving acceptable performance, enabling more efficient, cost-effective, and performant deployment in production environments. Question 5. Which model compression technique involves training a smaller, student model to mimic the behavior of a larger teacher model by learning from its ELIS soft targets? Option A. Quantization. Option B. Pruning. Option C. Knowledge distillation. Option D. Low-rank factorization. The correct answer is knowledge distillation. Here's the explanation. Knowledge distillation trains a smaller, simpler student model to mimic the behavior of a larger, more complex teacher model, learning from the soft targets, probability distributions, generated by the teacher. Question 6. A key challenge and consideration when applying model compression techniques is the trade-off between Option A. Model interpretability and data privacy. Option B. Training time and deployment cost. Option C. Reduction in model size/inference time and potential drop in model accuracy. Option D. Offline evaluation metrics and online monitoring metrics. The correct answer is reduction in model size/inference time and potential drop in model accuracy. Here's the explanation. The core challenge in model compression lies in finding the optimal balance between reduction in model size/inference time and the inevitable, albeit often minor, drop in model accuracy, making careful evaluation and monitoring an integral part of the compression workflow. Question 7. How does ML Ops application monitoring primarily differ from traditional application monitoring? Option A. ML Ops monitoring exclusively focuses on infrastructure health and resource utilization. Option B. ML Ops monitoring only tracks code performance and user experience for deterministic applications. Option C. ML Ops monitoring extends its scope to include model performance metrics, data drift, and concept drift for probabilistic ML systems. Option D. ML Ops monitoring is solely concerned with logging and auditing for compliance. correct answer is MLOps monitoring extends its scope to include model performance metrics, data drift, and concept drift for probabilistic ML systems. Here's the explanation. While traditional monitoring focuses on deterministic application aspects, MLOps monitoring uniquely expands to cover model-specific concerns such as predictive performance, accuracy, precision, recall, changes in input data distribution, data drift, and shifts in the relationship between features and targets, concept drift, which are critical for the reliability of ML systems. Question 8. An ML ops engineer observes that the distribution of input features for a deployed recommendation model has changed significantly compared to the data used during training. This change is causing the model to make less accurate recommendations. Which key feature of ML ops application monitoring is crucial for identifying this issue? Option A, traceability. Option B, concept drift detection. Option C, data monitoring, specifically data drift detection. Option D, automated remediation. The correct answer is data monitoring, specifically data drift detection. Here's the explanation. Data monitoring, particularly data drift detection, focuses on identifying changes in the statistical properties or distribution of input features over time compared to the training data. This is precisely what happens when the distribution of input features changes, leading to model degradation. Question 9. A real-time financial fraud detection system, powered by an ML model, is experiencing an increase in false positives, leading to legitimate transactions being flagged incorrectly. Which aspect of application monitoring would be most critical to detect this specific problem? Option A, monitoring CPU and GPU utilization of the inference endpoint. Option B, tracking network latency and throughput of the service. Option C, continuously tracking model performance metrics like precision and recall against ground truth. Option D, monitoring disk I/O for log storage. The correct answer is continuously tracking model performance metrics like precision and recall against ground truth. Here's the explanation. An increase in false positives, legitimate transactions flagged as fraud, directly impacts the precision metric. Continuously monitoring model performance metrics like precision and recall against ground truth labels is crucial for detecting such degradation in a fraud detection system, as highlighted in the detecting model performance degradation use case. Question 10. What is the primary goal of infrastructure monitoring in the context of MLOps? Option A, to track the accuracy and fairness metrics of deployed ML models. Option B, to manage and version different iterations of ML models and datasets. Option C, to collect, analyze, and act upon data related to underlying computational resources supporting ML workloads. Option D, to automate the training and deployment of ML models across various environments. The correct answer is to collect, analyze, and act upon data related to underlying computational resources supporting ML workloads. Quote, here's the explanation. Infrastructure monitoring focuses on the health and performance of the underlying resources, e.g. CPUs, GPUs, memory network, that support ML systems. Option A describes model monitoring, B describes a model registry/versioning, and D describes ML ops pipelines, or CI/CD. Question 11. An ML ops team observes high GPU memory utilization and spiking disk I/O latency during a deep learning training job. Which component of infrastructure monitoring would be most critical in immediately notifying the team about these issues? Option A, dashboards and visualization. Option B, metrics collection and aggregation. Option C, log management. Option D, alerting and notifications. The correct answer is alerting and notifications. Here's the explanation. While metrics collection gathers the data and dashboards visualize it, the alerting and notifications component is specifically responsible for defining thresholds and triggering immediate alerts when critical events or anomalies, such as high GPU memory utilization or spiking disk I/O, occur. Question 12. Which of the following best describes how infrastructure monitoring contributes to cost optimization in MLOps? Option A, it directly reduces the cost of cloud services by negotiating better rates. Option B, it identifies underutilized resources or inefficient configurations, allowing for right-sizing and better resource allocation. Option C, it automates the process of model retraining, saving manual labor costs. Option D, it primarily tracks the financial performance of ML models in production. The correct answer is, quote, it identifies underutilized resources or inefficient configurations, allowing for right-sizing and better resource allocation. Here's the explanation. Infrastructure monitoring provides granular data on resource usage, e.g. CPU, GPU, utilization. By analyzing this data, MLOps teams can identify instances that are over-provisioned or inefficiently used, enabling them to right-size resources and optimize cloud compute costs. It does not directly reduce cloud rates or track financial model performance. Question 13. A deployed machine learning model for predicting housing prices starts to show significantly lower accuracy because the economic factors influencing house prices have fundamentally changed. What type of drift is this model most likely experiencing? Option A. Data quality drift. Option B. Resource utilization drift. Option C. Data drift. Option D. Concept drift. The correct answer is concept drift. Here's the explanation. Concept drift detects changes in the relationship between the input features and the target variable. If economic factors change how housing prices are determined, the underlying concept, the model learned, has shifted, leading to degraded performance. Question 14. Which of the following is a key feature of model monitoring that requires ground truth labels to evaluate the model's effectiveness? Option A. Data drift detection. Option B. Concept drift detection. Option C. Model performance monitoring. Option D. Resource utilization monitoring. The correct answer is model performance monitoring. Here's the explanation. Model performance monitoring continuously tracks the model's predictive accuracy, precision, recall, or other relevant metrics using ground truth data as it becomes available. Data and concept drift detection can often be inferred without immediate ground truth. Question 15. When a model monitoring system detects that a deployed model's performance has degraded beyond acceptable thresholds, what is a common subsequent action in an MLOps pipeline? Option A. Automatically deleting the model from the production environment. Option B. Immediately deploying a new, randomly generated model version. Option C. Triggering an alert to stakeholders and potentially initiating a model retraining process or rollback. Option D. Increasing the computational resources allocated to the model indefinitely. The correct answer is, quote, triggering an alert to stakeholders and potentially initiating a model retraining process or rollback. Here's the explanation. If any monitored metric crosses a pre-configured threshold, the monitoring system triggers an alert to relevant teams. The insights gained from monitoring inform subsequent actions such as initiating a model retraining process or rolling back to an earlier model version. Question 16. Which of the following best describes the fundamental difference between data drift and concept drift in the context of MLOps data monitoring? Option A. Data drift refers to changes in the model's accuracy, while concept drift refers to changes in data volume. Option B. Data drift refers to changes in the statistical properties of input features, while concept drift refers to changes in the relationship between input features and the target variable. Option C. Data drift refers to changes in the model's infrastructure, while concept drift refers to changes in data types. Option D. Data drift refers to changes in the data's schema, while concept drift refers to changes in data freshness. The correct answer is data drift refers to changes in the statistical properties of input features, while concept drift refers to changes in the relationship between input features and the target variable. Here's the explanation. The study material explicitly states, data drift refers to changes in the input data distribution, PX, while concept drift refers to changes in the relationship between input features and the target variable, PX. This distinction is a very common exam focus. Question 17. An MLOps team is setting up a data monitoring system for a production model. Which of the following statistical metrics would be most appropriate for detecting data drift in a numerical feature? Option A. F1 score. Option B. Kullback-Leibler, KL, divergence. Option C. Root mean squared error, RMSE. Option D. Precision and recall. The correct answer is Kullback-Leibler, KL, divergence. Here's the explanation. The How It Works section lists Kullback-Leibler, KL, divergence, Jensen-Shannon, JS, divergence, Population Stability Index, PSI, Chi-squared test for categorical features, and Kolmogorov-Smirnov, KS, test for numerical features as common metrics for detecting data drift. F1 score, RMSE, precision, and recall are all model performance metrics, not data drift metrics. Question 18. What is the primary purpose of continuous data monitoring in MLOps for models deployed in production? Option A. To reduce the computational cost of model training. Option B. To ensure the reliability, performance, and integrity of ML models by detecting issues with input data before significant degradation. Option C. To facilitate the manual labeling of new training data. Option D. to only track the uptime of the model serving endpoint? The correct answer is to ensure the reliability, performance, and integrity of ML models by detecting issues with input data before significant degradation. Here's the explanation. The overview states its primary purpose is to ensure the reliability, performance, and integrity of ML models by detecting issues with their input data before they significantly degrade model predictions or lead to silent failures. The exam tips also highlight that it prevents silent failures and ensures model reliability. Question 19. A deployed fraud detection model begins to show a significant increase in false negatives, missed fraud, because new, sophisticated fraud techniques have emerged that were not represented in its original training data. This scenario is an example of which type of issue? Option A, data drift. Option B, prediction drift. Option C, concept drift. Option D, model bias. The correct answer is concept drift. Here's the explanation. The study material defines concept drift as changes in the underlying relationship between the input features and the target variable, indicating that the model's learned patterns are no longer valid. New fraud techniques changing the relationship between transaction features and fraud labels directly aligns with concept drift. Question 20. Which of the following is not explicitly listed as a key feature or component of model performance monitoring in an MLOps context? Option A, automated retraining triggers. Option B, data drift detection. Option C, model promotion workflows. Option D, visualization dashboards. The correct answer is model promotion workflows. Here's the explanation. While model promotion is a related MLOps concept, the key features/components section for model performance monitoring lists automated retraining triggers, data drift detection, and visualization dashboards. Model promotion workflows are a distinct process, not a component of monitoring itself. Question 21. What is the primary goal of model performance monitoring in an MLOps context? Option A, to perform A/B testing of new model versions before full deployment. Option B, to continuously observe and evaluate the behavior and effectiveness of deployed ML models proactively. Option C, to archive old model versions and their associated data for historical record keeping. Option D, to log and organize metadata about machine learning experiments during development. The correct answer is, quote, to continuously observe and evaluate the behavior and effectiveness of deployed ML models proactively. Here's the explanation. The overview states, the primary goal of model performance monitoring is to detect these issues proactively, ensuring that models continue to deliver the expected value and maintain their integrity in real-world scenarios. Question 22. What is the fundamental characteristic of concept drift that directly impacts the long-term performance of deployed machine learning models? Option A, the model's training data size continuously increases over time. Option B, the underlying statistical properties of the target variable or its relationship with features change over time. Option C, the computational resources allocated to the model decrease over time. Option D, the model's codebase is updated frequently with new features. The correct answer is, the underlying statistical properties of the target variable or its relationship with features change over time. Here's the explanation. Concept drift refers to the phenomenon where the underlying statistical properties of the target variable, or the relationship between the input features and the target variable, change over time, causing a deployed model to become less accurate. Question 23. An e-commerce recommendation system suddenly starts suggesting irrelevant products to users. Upon investigation, engineers find that user preferences and popular trends have shifted significantly due to a new viral social media challenge. Which type of concept drift is most likely occurring? Option A, gradual drift. Option B, incremental drift. Option C, sudden drift. Option D, recurring drift. The correct answer is sudden drift. Here's the explanation. Sudden drift describes an abrupt and significant change in the concept, often due to an external event like a new product launch, or a sudden shift in trends, which aligns with the scenario of a viral social media challenge altering user preferences. Question 24. Which of the following is the most common and effective response to detected concept drift in a deployed ML model? Option A, increasing the model's prediction confidence threshold. Option B, retraining the model on a new, more recent dataset. Option C, reducing the frequency of model predictions. Option D, deploying the model to a different geographic region. The correct answer is, quote, retraining the model on a new, more recent dataset. Here's the explanation. The most common and effective response to detected concept drift is to retrain the model on a new, more recent dataset that captures the evolved concept. ensuring the model's decision boundary remains optimal. Question 25. An ML ops team observes that the distribution of fraud scores predicted by their model in production has significantly shifted compared to its initial deployment. This change is occurring even though the input features, distributions, data drift, have remained relatively stable. What specific type of drift is primarily being observed? Option A, data drift. Option B, concept drift. Option C, prediction drift. Option D, feature drift. The correct answer is prediction drift. Here's the explanation. Prediction drift specifically refers to a significant change in the statistical distribution of a machine learning model's outputs, predictions, over time. It is distinct from data drift, changes in input features, and concept drift, changes in the relationship between inputs and outputs. Question 26. What is a crucial initial step when setting up a system for detecting prediction drift in an ML ops pipeline? Option A, immediately retraining the model with new data. Option B, establishing a baseline distribution of predictions from the model's optimal performance period. Option C, disabling all other forms of model monitoring. Option D, manually reviewing every single prediction made by the model. The correct answer is establishing a baseline distribution of predictions from the model's optimal performance period. Here's the explanation. The mechanism for detecting prediction drift begins with baseline establishment. A reference distribution of predictions is captured from training, validation, or initial successful deployment, representing the model's expected behavior when performing optimally. Subsequent predictions are then compared against this baseline. Question 27. A personalized recommendation engine deployed in an e-commerce platform shows significant prediction drift, where the distribution of recommended product categories has shifted unexpectedly. What is the most direct business consequence of this drift? And what is a common mitigation strategy? Option A, increased system latency. Optimize the model serving infrastructure. Option B, decreased user engagement and sales. Retrain the model with updated user preferences and product data. Option C, regulatory non-compliance. Implement stricter access controls for PII. Option D, higher false positive rates in fraud detection. Adjust the model's classification threshold. The correct answer is decreased user engagement and sales. Retrain the model with updated user preferences and product data. Here's the explanation. For recommendation engines, if the distribution of recommended products drifts, it indicates the model is becoming less relevant, leading to decreased user engagement and sales. A common mitigation strategy is retraining the model with fresh, representative data, such as updated user preferences and product information. Question 28. Which of the following best defines feature drift in the context of machine learning operations, MLOps? Option A, a change in the relationship between input features and the target variable. Option B, a phenomenon where the statistical properties or distribution of the input features used by a machine learning model change over time. Option C, a decline in a model's overall performance over time in production. Option D, the process of selecting the most relevant features for a model. The correct answer is a phenomenon where the statistical properties or distribution of the input features used by a machine learning model change over time. Here's the explanation. Feature drift specifically refers to the change in the statistical properties or distribution of input features over time, which can lead to model performance degradation. Option A describes concept drift, and C describes model degradation, which feature drift can cause. Question 29. When monitoring for feature drift in continuous numerical features, which statistical test is commonly used to quantify the difference between two distributions? Option A, chi-squared test. Option B, Jensen-Shannon, JS, divergence. Option C, Kolmogorov-Smirnov, KS, test. Option D, mean absolute error, MAE. The correct answer is Kolmogorov-Smirnov, KS, test. Here's the explanation. The Kolmogorov-Smirnov KS test is explicitly mentioned for continuous features to compare their distributions. Jensen-Shannon divergence can also be used for continuous features, but KS is a specific test for continuous distributions. The chi-squared test is typically used for categorical features, and MAE is a model performance metric, not a drift metric. Question 30. Upon detecting significant feature drift, what is a primary mitigation strategy in an MLOps framework to maintain model effectiveness? Option A, manually adjusting the model's predictions based on expert human judgment. Option B, increasing the model's complexity to automatically adapt to new data patterns. Option C, reducing the frequency of data collection to minimize exposure to drifted features. Option D, triggering automated model retraining with newly collected, representative data. The correct answer is triggering automated model retraining with newly collected, representative data. Here's the explanation. Automated model retraining using new, representative data, is a core mitigation strategy for feature drift. This allows the model to learn from the updated data distribution and regain its predictive performance. Other options are either ineffective or counterproductive. Thanks for watching. Please subscribe to my channel